Hi guys, we're going to be taking a quiz on section 5.3 graphing polynomial functions soon, so I wanted to go over a review with you. So this is the review I'm going to send you. I'm going to do some problems with you and then leave some blank. Whatever I leave blank is going to be yours to do on your own as the homework that you'll submit to me. All right, so graphing polynomial functions, right? We're sketching their graphs. It's all based off of the degree, the leading coefficient that get us that end behavior, and then the official points that we put on the graph are the x-intercepts, the zeros, right? Okay, so in this part, they say for each graph, describe the end behavior, determine whether it represents an odd degree or an even degree function, and state the number of real zeros. Okay, so end behavior, right? Well, look at this graph. I think we could easily all agree that both ends of the graph end up. So if they both end up, we have to kind of talk about their end behavior in this fancy talk. So this says as x goes to infinity. So that means as x gets bigger. Well, x lives on the x-axis. So x gets bigger and heads toward infinity this way. So as x gets bigger, what's f of x doing? What's y doing? Because f of x is y. So as x gets bigger, what's y going to do? He's going to continue to get bigger. So y is headed towards what y value? Infinity. Okay. Well, what about as x goes to negative infinity? So as x goes to negative infinity, that means x is getting smaller. So as x goes to negative infinity, what's f of x or y doing? He's getting bigger. So f of x or y is heading to infinity. And that makes sense because if they have the same end behavior, if they both end up, then your f of x's should head towards the same infinity. All right, well, is this an even or odd polynomial function? Well, guys, if both ends end up, is that the end behavior of an even degree polynomial or an odd degree? Well, if they end both up in the same direction, that means the polynomial function had to be even, because even polynomials have the same end behavior. Odd degree polynomials have different end behavior. One end is up and one end is down. So if they both end up, that had to be an even degree polynomial. Well, then they're asking you, is the leading coefficient, LC, is the leading coefficient positive or negative? Well, guys, if both ends ended up, would that have been a positive leading coefficient or a negative leading coefficient that did that? It would have been a positive leading coefficient, right? If it was a negative leading coefficient, they would have had to end both down. All right, and then it asks for the number of real zeros. Well, remember, zeros are just a fancy name for x-intercepts. So how many real x-intercepts do you have? Well, count the number of times that it crosses the x-axis and take note as to how it crosses. Does it cross, or does it bounce, or does it kind of flatten out as it crosses? Well, look, it crosses like normal, so that's one real zero. It crosses like normal, so that's two real zeros. It crosses like normal, so that's a third real zero. It crosses like normal, so that's a fourth real zero. It crosses like normal, so that's a fifth real zero. And then it crosses like normal, so that's a sixth real zero. So this graph is showing that there are 6 real zeros, 6 real x-intercepts, 6 real times that it'll cross the x-axis, okay? And again, remember, they're saying real because sometimes when you set a factor equal to 0 and solve, you get an imaginary 0. And then those are not x-intercepts. That's not where the graph can cross the x-axis because they're not real numbers. All right, look at number 2. All right, looks like a parabola. So as x goes to infinity, as x gets bigger, where's f of x or y going? So as x gets bigger, where's f of x going? It's going to negative infinity. All right, well, as x goes to negative infinity, as x gets smaller, where's f of x still going? To negative infinity. Okay, well, is this the graph of an even or odd polynomial? Well, if the end behavior is the same, if they're both down, was this an even or odd degree? It would have to be even since the end behavior is the same. All right, well, is the leading coefficient positive or is the leading coefficient negative? Well, if they both ended down, that would be because the leading coefficient is negative. Okay, all right, and then they asked you to count the number of real zeros. Well, guys, it definitely crosses at -2, but how does it cross? It bounces, right? Which means it had to have multiplicity of at least 2. It had to have even multiplicity. So maybe it was the same answer 2 times, or maybe it was the same answer 4 times, or maybe it was the same answer 6 times. When we're doing this, we just assume that it's the lowest one possible. So we'd have to assume that he was an x-intercept of -2 twice. He would have had to have been at least a double root to make that bounce. So we're going to say the number of real zeros is 2. Now, I guess it could be argued that it's just 1, but if it was just 1, then it could qualify as a degree 1 polynomial. With at least 2 real zeros, we're showing that it's a degree 2, and it's following that even end behavior, okay? All right, I'm going to leave this one for you guys to do, all right? Let's look at number 4. For questions 4 through 6, fill in the end behavior of each function. So now they're going to ask you to fill in the end behavior without even seeing the graph. All right, so let's look at number 4. If we had to predict this end behavior of this polynomial function without seeing his graph, well, let's use the hints I gave you, right? Well, look at the hint. First, you're going to need to know his degree. What degree is this polynomial function? It's a degree 3. Okay, well, who's the leading coefficient? The leading coefficient, the number in front of that leading term, the one with the highest exponent and variable, is -1. Well, let's kind of pinpoint what the end behavior of this graph would have been. If it's odd degree, what would the end behavior have been? 1 up, 1 down, right? The end behavior has to be different. Well, if the leading coefficient is negative, which end of the graph would have been up and which end of the graph would have been down? Well, if the leading coefficient is negative, remember, it ends up on the left to the left of your last x-intercept, and it ends down on the right to the right of your last x-intercept. So now we can fill in the end behavior based on what we know. It's going to end up over here and down over here. So as x goes to infinity, as x gets bigger, where's f of x going if it's down here? F of x is going down, which is towards -infinity. All right, well, what about this one? As x goes to -infinity, as x goes to -infinity, where is f of x going? Well, if the graph has to end up here, where's f of x going? It's going up, which means it's going towards infinity. All right, let's look at this one. You know what? Maybe I'll leave that one for you guys to do, and I'll do this one. Okay. Well, this one isn't in multiplied out form. So in order for me to figure out the degree and the leading coefficient, the ones that predict his behavior, remember, I can't treat this as the leading term. It has to be in multiplied out form in order to kind of find that degree and that leading coefficient. So think about it. This would have been -x² times x plus 3 times, there are really 3 factors of x minus 1. So if I multiplied all my fronts, a -x² times x is -x to the 3rd. Times x is -x to the 4th. Times x is -x to the 5th. Times x is -x to the 6th. So that one definitely would have led with a -x to the 6th term. Okay, all right, so let's figure it out. What's the degree? The degree is 6, which means it's even, and the leading coefficient is -1. So if the degree is even, what would the end behavior had to have been? The end behavior would have had to have been the same, either both up or both down. If the leading coefficient is negative, which one is it? They would have both been down. So I would have ended down to the left of my last x-intercept, and it would have ended down to the right of my last x-intercept. So now we can fill in the end behavior. As x goes to infinity, so as x gets bigger, where's f of x or y going? Well, if the graph ended down here, f of x would have been going towards -infinity. All right, well, look here. As x goes to -infinity, so as x goes to -infinity and gets smaller and smaller and smaller, what's f of x or y doing? It would be going down, ending down here, so it would be going to -infinity as well. And again, an even degree polynomial should have the same